Another type of graph that we like to use to model our statistics is the box and whisker plot. And if you recall, the box and whisker plot is all based on finding quartiles for your data. I have here a set of psychology test scores that were created by 22 students. You'll notice the low score was a 42 and the high was a 99. We want to create a box and whisker plot out of this data. And essentially we need to get our data divided into 4 equal parts. And the easiest way to do that is to find the middle and then cut the middle in half. So the first thing we need to find is the median. In this case, since there are 22 students, I need to know where to count to find the median, and I'm not going to sit there and cross off. So I'm going to go, hey, 22 students divided by 2. This is an even number, so I know the median is going to fall right down the middle. So if I divide that by 2, I'm going to get 11. So it tells me it's going to fall between the 11th and 12th numbers in this list. You can count from either end, it doesn't matter, to find the median. I'm going to just simply count from the top, 42. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the median falls between 76 and 78. Since it falls between 2 numbers, we must actually calculate it by averaging 76 and 78, which I'm sure you're already going, hey, that's 77. So we have a median of 77. Okay, then we need to divide each of the halves we have here in half so that we get quarters, hence our quartiles. So if I want to find quartiles, I first have to figure out how many numbers are in each half. Well, since I divided between 11 and 12, I know that means there's 11 numbers in the top half and 11 numbers in the bottom half. So if I'm going to do the quartiles then, 11 divided by 2, this is an odd number this time, is 5.5. So I know if I cross off from each end, I would be left with one in the middle, which will then round up and be the 6th number will be where the quartile falls. So once again, counting from the top, 1, 2, 3, 4, 5, 6, lands right on 69. I need to do the same thing for the bottom half of these numbers. I'm going to start at the median and count. You could also count from the very bottom of the stem and leaf plot. I would have 1, 2, 3, 4, 5, 6 numbers. So pay attention to which is the smaller and the bigger number. We call the higher number the upper quartile. So or sometimes on your calculator, the upper quartile will be Q3. And so that's an 86. On the bottom, we call it the lower quartile, sometimes called Q1, and that is a 69. From here on out, I will abbreviate upper quartile as UQ and lower quartile as LQ, just to make it faster. Okay. If you recall, those 3 numbers form the box of your box and whisker. I have a scale down here at the bottom already created, and so I would take those 3 numbers, my 77, where the median falls, 86, and 69, and those 3 would form the box of my box and whisker. Okay, the question is, where do I draw the whiskers to? You normally draw the whiskers to the highest and lowest numbers in the data. So on a normal situation, I would draw the whisker out to 42 since it's the lowest number, and I would draw the other whisker to 99 since it's the highest number. However, hopefully you're out there going, but wait, there might be outliers. And so how do I know if there are outliers? Well, outliers are found if a point lies more than 1.5 boxes away from the box. Okay, so I'll say that again. If you take the length of the box, which is called the interquartile range, and take it times 1.5 so that you're 1.5 away. If your data falls more than 1.5 away from the edges of the box, it's an outlier. So first we would have to calculate the interquartile range. Which is better known as the IQR. At least it's a quicker way to write it. So in our case, to find an interquartile range, it's simply the upper quartile minus the lower quartile. In our case, that means it's 86 minus 69, or 17. That means the box is 17 units wide. To be an outlier, we must have something that's more than 1.5 boxes away. So I would need to go calculate my outliers by taking the interquartile range times 1.5. So the interquartile range would be 17 times 1.5, which would give us 25.5. If we have any data that's more than 25.5 away from the edges of the box, it's an outlier. So we need to find where those boundaries at. So if I want to find the lower boundary on my box and whisker, I'm going to start at the bottom edge of the box, which is the lower quartile, and I'm going to subtract this number I just calculated. So in this case, my lower quartile was 69, and I would subtract the 25.5. That is going to give me 43.5. I'll come back and deal with that in a minute. On the other side, if I want to know what's the high side boundary for my outliers, I would do the same thing, except I would start on the top edge of the box, which is the upper quartile, and I would add the number we calculated. So I would have 86 plus 25.5, which is 111.5. Okay, then you need to look at your data, the actual data in the stem and leaf. Did we have any data that was higher than 111.5? And the answer would be no. The highest we had was 99. So therefore, there is no outlier on the high side. But on the low side, did we have any data that was below 43.5? And yes, indeed we did. We had a data point at 42. So therefore, 42 is an outlier. I have to come back over here then and erase my whisker. Since 42 is an outlier, I would put just a dot at 42. My whisker would be drawn to the next piece of data. Emphasis, what's the next number in your data that was not an outlier? Well, from 42, if you look at the stem and leaf, 58 was my next piece of data, so I would have to go from 58 would be where my whisker is, which then shows me how spread my data is. I can see that my box is pretty evenly spaced, and then I have that one wild value of 42 that was down lower, but most of the rest of the quartiles are fairly even. So on this particular test, there was a fairly even spread. I would prefer to see all my students packed on the high side if I was giving this test, and have very little data on the low side, but this is pretty evenly spaced. Okay, in a moment you'll also find a video on how to create a box and whisker plot on your calculator. Hopefully this will help.